Dear students, now we will look at the fifth learning outcome, which is how to determine the confidence interval for population mean. So confidence interval is determining the specific interval, which is an estimate of a parameter by using a data from a sample. And confidence in this confidence interval depends on a specific level of confidence level. So the confidence level can vary between 80 to 99%. So the formulas which are related to confidence interval are stated over here, as you can see. So x bar here means sample mean plus minus. It's plus minus because we have an interval. It's always an interval. So these three formulas will actually give you confidence interval. You can use any one of these formula to answer the questions related to confidence interval. So the first one, that's why it has a plus minus, because the next two formulas actually has an interval on the left and also to the right. So you see the left is a minus, the right is a positive, yeah, plus. Same goes with the third formula. The minus is on the left because the lower value is always on the left, and then comma, and then the higher value is on the right. But please write it in a particular format. Yeah, so later on I will show you examples related to confidence interval. So I'll just explain to you what all the symbols here mean. X bar here is sample mean. Z alpha over 2 is the confidence level that I mentioned just now. So for a different percentage of confidence level, you will have a specific Z alpha over 2 value, which will be shown in the coming slides. Standard deviation is sigma here is standard deviation of a sample, and n here is a sample size. Okay, so same. The next two formulas uses the same kind of parameters, just that it's written in a different way. So next, we'll look at the confidence interval and also the corresponding Z alpha over 2 value, the critical value, which is called the critical value. So if it's 80%, it's 1.28, and 90 is 1.645, 95, 1.96, and 98 and 99 is so on. So questions related to confidence interval, you must take the percentage into account in order to use the specific critical value. For example, we wish to estimate the mean serum indirect bilirubin level of a 4-day-old infant. Okay, so the mean for a sample is 16 infants. So here very clear, the n is a 16. That's the sample size. Was found to be 5.98. So this is x bar. X bar is 5.98, n is 16. Okay, so example, n equals to 16 over here. As you read, you must get the mathematical information out. Yeah. So x bar is simply 5.98. Okay. Assuming bilirubin levels in 4-day-old infants are approximately normally distributed. So this is a keyword to let you know that this is related to normal distribution. The level of bilirubin is normally distributed, yeah, with a standard deviation of 3.5. So standard deviation here is standard deviation equals to 3.5. Right, so as you read, you must identify the values of, and find 90%, next is 95%, and next is 99% of confidence interval for mean. So I will show you the working for all three. So for 90%, from the table from the previous slide I've shown you, Z is 1.645, Z alpha over 2, yeah. So the formula, I showed you the formula for the first one. Using the first formula in the previous slides, 5.98 is x bar plus minus Z alpha over 2, which is 1.645, multiplied by standard deviation over set of n. So you just plug in the formula and you will arrive to this calculation. you need to calculate your values. You need to know the plus and the minus. So another way of writing is 5.98 minus the lower values on the left and 5.98 plus Z alpha over 2 multiplied by standard deviation over Z. Okay, and when you get the values, make sure you write in such a way, bracket, lower value on the left and higher value on the right. Okay, the sequence has to be correct. Okay, and the interpretation for the 90% simply means we estimate the population mean to be 5.98, that is already given. So that the best interpretation says we are 95% confident, 90% confident that the true value of the mean lies between the values you calculated here, the lower and the upper boundary for the 90% interval. Okay, next we will look at the next interval, which was stated was 95%. From the table provided, when the confidence level is at 95%, the critical value for the z alpha over 2 is 1.96. Okay, so what you do is you plug in the values accordingly. X bar 5.98 plus minus z alpha over 2, which is 1.96, multiplied by standard deviation over set of n, you get this value. Okay, calculate both sides, you get the lower end and the upper end value. So when we are for this particular interval, the interpretation will be we are 95% confident that the true value of the mean lies between 4.265 and 7.695. So the same goes for the 99% interval, where the z value is 2.575. Okay, so you plug it into the formula, which is x bar 5.98 plus minus z alpha over 2, which is 2.575, multiplied by this part here is actually standard deviation over set n. So remember this, yeah, this is standard deviation over set. Calculate it and then you just plug it in and you will get the lower and upper boundary. So make sure you write it from the lower to the higher value, and your interpretation, because it's a 99% interval, so we are 99% confident that the true value of the mean lies between the lower and the upper confidence level that you calculated.